So I kind of already went over this. We'll be covering 3 different platforms, 3 different developers. We're building one app, and this certainly will not be a deep dive on each one of these platforms, but the goal is to rather whet your appetite and give you a good idea of what it takes to work in these systems. So it should be a little bit better than spending an hour poking around on the site and trying to figure it out, hopefully. And then, of course, we'll do, each of us will kind of have a different style of how we present, demos, code walkthroughs, and what have yous. This is, I don't know if you can see that too well, it's a little dark in here. So this is the app we'll be building. It's called QuipVid, and some of you that know me might be familiar with the name of this. But this is a project that I started a couple years ago, and in its most simple form, it's a website for movie quotes. And recently started turning it into an actual mobile application. So the idea being that you come here, you search for a quote, you find it, you can share it, you can put it on Facebook, text message, whatever. So the website's been around for a while. Myself and 2 others recently started taking this project seriously. And I've had a mobile app that I've done myself that only I use, and it makes it so much easier than using the website. So I kind of had it all fleshed out, and I thought, what the hell, let's see what 2 other people can do with it. And so this is the project that I gave the other people to execute. So real simple. You land on the first screen, you'll get a list. This is not ideal, but you'll get a list of all the videos that are offered on there. You can search them, and when you click into one, the video will play. You can share it, and it's about that simple. So that's what we're going to be building. The version you're seeing right here is the full-on Swift version that I've done. So what you see will actually look, a little bit different, but along the same lines. So what we're going to be covering, I will be handling NativeScript, Logan Sparlin, right there, React Native, and Fred Lawler on Cordova. So maybe you've heard at least of one of these things, a couple of them, but hopefully not all of them, so you can get an idea of what it's about. So, NativeScript. What the heck is it? Anyone familiar? NativeScript? I was not. I heard about it a year and a half ago, something like that. We were at a conference, and there was a whole session on NativeScript. I had no idea what it was. So NativeScript is brought to you by Telerik, and what it is it's a JavaScript runtime that basically produces native code. And so we'll be talking about this more and more as we go on, the difference between native and hybrid. For all intents and purposes, NativeScript is, as it says, a native application. So it's not a web wrapper that sets inside of a native application. It truly is a native app. But you write with JavaScript, so there's a number of APIs that you interface with, and it feels just as comfortable as writing JavaScript. You can use XML for your markup, or you can just use pure JavaScript. It is cross-platform. It will produce iOS and Android applications. However, for the demo tonight, you'll only see the iOS one. I went to go do Android and found some issues with that, but it should, for the most part, be trivial, especially compared to building out an entirely other Android application. And performance. This will be something we talk about more and more this evening. The difference between a hybrid and a native app, to the keen eye, performance is really big, especially when it comes to things like scrolling. If you're scrolling a long list and you are not using a real native application, there's a good chance you'll feel that lag, you'll see the stutter. So we'll be touching on that. This was from their site. It was start in no time. I thought, awesome, because I don't have any time. npm install globally NativeScript. I think most of us are going to be familiar with this. If not, just know that this will install the NativeScript platform on your system globally. The next line down to create a project is TNS, which is Telerik NativeScript, create, and then the name of the application, and this will spit out a core app for you. Then you have the choice of what platform you want to target. So you can either do iOS, Android, both, or just one. So TNS platform add, name of the platform. And then to run it, it's just as you see here, TNS run Android emulator. There's another variant of this command that will not only run the app in your system's emulator, but it will also keep track of any changes happening. So it runs live reload, essentially. And that way when you change a file, you don't have to stop the app from running and build it again. It'll just rebuild it on the fly. And it takes, depending on, you know, if it's iOS or Android, it can take anywhere from 3 seconds to 20 seconds kind of thing. So that is the getting started here. Now I mentioned that that this calls native APIs, and I don't know if you're anything like me, these things never make any sense. I really have to study them. This one seems actually pretty easy. So at the bottom, you start with JavaScript, which again, we're web developers, so we know JavaScript for the most part. We write that, and it basically goes up the chain, scrubs any sort of metadata it can, and then essentially what these next 3 boxes are implying is that it's converting it all into native code, and it will call back into your JavaScript. So you'll basically send a signal out saying, I'm doing this. It will send something back to your JavaScript code, like you got a video. What do you want to do with it? I want to play it. And then your play signal goes back out, comes back in. And then over to the right here, we see JavaScript libraries. And this was an interesting thing to me. When I was reading through their documentation, it was all, bring any node package you want. Well, hell, that's great, because I like node packages. It wasn't that smooth. It broke on a lot of things, but I think you can kind of use common sense and know that if it's just doing, some more low-level functioning kind of stuff, you're probably going to be all right. But, if you've got a node package that's trying to do all sorts of, front-endy type executions, there's a chance that it's probably not going to translate well going up to that native API. There are a number of plugins created by third-party vendors, people, whatever, that are specifically made for NativeScript, and you can be confident that those will work pretty well. So, before we jump into code, any questions? What's up?
There's a Windows icon up there, but you said iOS and Android. I was just curious. Is it?
Oh yeah, that's a good question. You know what? I've dug through their documentation and not seen any reference of Windows. So this might be an old piece. I don't know, or it might legitimately support it. I think Windows Phone is kind of dying off anyways, unfortunately. But I don't know. That's a really good question. I did not catch that. Any others? Catch anything else on there? Sweet. Okay. The demo is going to be pretty light, so don't expect anything super crazy. Oh, I guess that's as large as it wants to go. Okay, so this is the main part of the app here. You can kind of see the folder structure on the left there, a little bit at least. You'll see that there's not much, right? I basically have a main page, kind of group of files, and then a quip page, and then a couple of other bootstrappy type things, right? So all I'm doing here is it's setting up the application, and all this line says is you're basically starting with the module main page. I chose to do my, there we go. I chose to do my demo using the variant of NativeScript of XML and essentially plain JavaScript, even though I am using TypeScript for no good reason. I'm not even using anything TypeScripty. You can use, they have another variant of using Angular 2 and TypeScript. So if you're an Angular person and you're like all in on Angular 2, which I am one of those people, then it feels very, very familiar to you. But you don't have to do that way. You can use this kind of, I guess I kind of like to refer to as a little bit more old school way, or maybe even a little bit more webby, right? This looks like HTML. We know how to lay this out. It's just got some other decoration in there, but that's about it. So main page points to this main page XML, and the system will automatically assume that there's a matching file name of either, well, it will be .js, so main page.js. It's expecting that. It's essentially considers its code behind file. So anything you have in here will automatically reference that file. So let's just kind of start at the top here real quick. And if you can kind of keep a mental model of what that app looked like, at this top we start with an action bar. So that basically just gives the title at the very top. Below that we have a stack layout. And this is a term that I think is a little bit more ubiquitous for iOS because it's a new UI feature in there. But basically, just think of it as a container. It's going to stack things in this container. And then inside of that, we have a search bar. And notice, again, I'm using things that are very Familiar with this, right? Width 100%. Then we see some of these other things. Vertical alignment center. These are all things that NativeScript has an API for and will deal with. But you can decorate it up with most of the stuff you're familiar with. Clear here is actually, it knows it's a search bar, so clear is a function, and you could read through this in the documentation, and clear search is a function that will get called in the JavaScript file. And same with property change, search quips. We'll see that in a second. And then below that, I won't dig into the nitty-gritty details here, but basically we have a list view of items. So by default, this will come back with a list of everything in there, and specifically I think it's about 420 items that come back. We loop through it, and we see the template in there, and then inside of that you see this absolute layout. It's kind of interesting. Normally you'd consider that like, you know, don't do that on the web, right? But in mobile, it kind of makes a hell of a lot more sense. When you're actually doing native development, a lot of times you'll find yourself positioning things in ways that you wouldn't really think to do on the web. And speaking as a web developer, that's kind of hindered my process, my learning process of mobile, because I'm thinking box model, right? I'm thinking web, and it just doesn't work like that. So for this one anyways, absolute layout made sense. It was pretty easy stuff in here. A couple of labels, and that's the gist of it. So the back end of this, I will not call this pretty code by any means. Another reason I chose not to go the Angular 2 route for this demo was I didn't want anybody to really get tied up on, well, what's going on with Angular 2 there? That looks really weird. What are these components and these things? So hopefully, although this is ugly, hopefully it should be at least decently expressive enough to understand what's going on here. So on navigate to, that's essentially the page has been navigated to, and really all I'm doing here is setting the page binding up to a function called create view model, and that's essentially what fetches all those quips and loads them in there. I ran into an interesting issue. When you would go to a detail page and it would transition into that, and you would come back, it would try and create that view model again that already existed. So basically here I'm just checking if there's no binding context, then do it. Otherwise it would come back and it would just keep trying to create it. So just some weird bugs. Not bugs, but just weird architecture, I suppose. Loaded, and you can call anything you want on loaded. I'm not doing anything. Create view model, this is the thing that gets called. Here, I'm reading, so I fetch those items and then I store them to a text file. So I cache everything, I make that call and then cache everything locally. Again, another nice thing about working with truly native is that you have access to the file system. So I store that down and I can bring it back anytime I want. I happen to be storing it as JSON, so I know when that comes back, I can get at that content any way we normally would get at JSON content. And then that store in memory quips, so it just passes that off there. The get quips is also called up here. That just does HTTP call, brings it back, stores them. List item view tap. So if I come back over here, should see. Oh, never mind. I think that's an old one. My bad. Come back to it if we need to. Search quips. So this function right here, search quips, is called on property change of that search box. So anytime that changes, it will automatically call this in here, and it'll get that text value in there. One thing that I found very interesting, I know we're kind of scooting back and forth here, this was actually something I kind of liked about this setup. Anytime you call an event here, oops, sorry, you can't really see that. So property change is an event, and you figure that out by way of the documentation. Anytime you call an event, any other attribute, it could be anything, right? I could put blah and set it to 1, 2, 3. Anything on here is accessible back in that function. So I'm sitting here like, yeah, how do I get, I'm tapping on something down here, how do I get the index of the item it's at up the chain? Well, it turns out it was pretty damn easy. All you got to do is throw it on that element, and it will get that in its args value there. So basically if search is set, just do a filter down here, doing a simple filter. I'm basically checking if the name or the title includes what's being searched, bring it back. And then, oh, sorry, this is probably one of the last things we'll hit on here. The view model. So this was a little bit weird. Up at the top, I set up this observable. So it's an observable array, so anytime this changes, anything attached and bound to it on the front end will automatically pick up those changes, and you get that by setting up that observable. Well, with the filtering and such, I didn't want to do away with the list, the full list of things I had back, and the filtered list. So what I did was just set up an array out there, and that's where like the real list of things get stored, and then I manipulate that view model however I need to. So back down in here on search quips, basically I just rip through every item and pop it off, and then push in the filtered results in there, and that automatically will update that list view. And it's pretty stupid fast, you'll see in a second. Clear search, pretty self-explanatory. Again, ripping through those, popping them off. That's all there is to it. Show quip. Sorry, this is probably two last things. Out on here, there's a play button, and on tap, it's going to show quip. And then notice here, I've got that ID, which it already has from looping through there. It has access to it. So back in here on show quip, I set up a little function, get quip by ID, pass in that ID, and then this is really where the magic happens here. Just setting some navigation options in here. This is the module name that it's going to go to. So you'll remember that back here in app.js, the bootstrap point. So my module name was main page. Now in here, it's going to the quip page, and then passes in the data context, and then this frame module, topmost, navigate. Now, one thing I can't answer for certain is if this is specific code to iOS, or if this is one of those things that will work, on both systems. But basically what this will do is navigate to that next piece in there, and it'll give you that animation by default. So when you click it, it zooms over, slides over rather. Share quip, in the front end there, we have a function set up there, and we're calling social share image. This is one of those examples of a third-party plugin. The system didn't have a share option built into it, but somebody built one, and it does work both on Android and iOS. So, with one line of code there, essentially I took care of both platforms pretty stinking easy. And then just a little helper functions down there, and nastily exporting out these functions. It's pretty gross. Take a real quick look at the quip page here. Passes in that name, which is the getting, and then we have a stack layout with a video player. And the one interesting thing to note about this is another third-party plugin. It didn't have a video player, which is just, I find weird. It's such a common thing, you think it would be in there. So over here, video player, I'm setting to NativeScript video player. And that's on the front end. That's essentially how you pass in a plugin instance to your view. Then you can access it that way. So now I've got this video player component or element, if you will. Pass in source, autoplay, right? Looks like HTML5. Set a height on there, and that's it. Whew. And just a couple little helper methods in here to play it. And actually, there's one when I navigate from, when I back out of it, I stop playing the video. And actually, that's something I had to customize, is this video destroy. I had to go in there and actually add that functionality. Otherwise, I would hit back and it would just keep playing. So I added that in there. It's a bit long-winded, so finally, let's just show what it looks like to run this. I know you can't see that for anything. TNS live sync iOS -- emulator -- watch. I'll flip back over, and in a moment we should see the emulator come up.
Before we wait this, you mentioned that you were doing absolute heights and widths.
Yeah.
Does the framework support multiple devices? So like I know in native development you usually have different layouts for different devices. Does it have the ability to have different XML for different devices?
I would like to say yes, but I honestly can't answer it with full confidence. I would think so, because that's the core of laying this stuff out. You can deal with percentages in here, so naturally it should work. But what I don't know is, I can't speak for Android, but I've done a bit of iOS work. With iOS, you can basically tell it, I'm on a small or a large device, and lay it out differently based on the fact that I'm on these different sizes. I've not come across that at all in here. So if it is in there, it's certainly not touted. So, I don't know.
You have a different layout per device.
Right, yeah. Yeah, I don't know if it has it or not, unfortunately. It does work, so yikes. So there you can see an example of what it looks like working with Absolute, right? Come on. There you go. So here's a list, right? Let's. So you saw the flash there for a little bit. There is image caching on here. So it should not flash again as it comes across that image. So if we search Marmot, it's right there, right? Office space is pretty. I mean, pretty fast. I'm pretty tickled by the performance of something that, you know, is, I'm not really working in native, but it does come out that way, and it feels pretty dang good. So you play, we're gonna get any, whatever.
So, anybody see any good movies lately?
Yeah, not really, no.
Oh. Read any good books?
No.
No. Anything new with corn?
Oh, yeah, corn.
Oh, yeah, corn. You bet.
Corn, yeah.
And going back, we'll cut that off. And I know that seems trivial, right? But like,
I
I
thoroughly
was sitting here
enjoyed
playing
my
this, I
trip
go
to the
back, and it was still playing, and it was a total pain in the ass. I don't know how well, especially on this, because I can't scroll very good. But trust me, it scrolls super fast, which, you know, can be an issue on other platforms. And I've got this on my phone, so afterwards, if you want to poke around with it, you know, you can feel free to look at it, and also compare it to like the raw Swift version that I have too. And then lastly, the share. It's a simulator, so it doesn't have much on there, but basically if you had Facebook or whatever, it would pop up on there and you could share it on basically whatever your phone sees as something that can take a URL or whatever you're trying to share. So probably went a little bit longer than I wanted to. We'll get Logan queued up next, and if you have any questions, I can take them as we're kind of tearing down. So.
Okay, cool. Hey, what's up? I'm Logan Sparlin. I'm a user interface developer across the street at Marlin. Like you said, I'm going to talk a little bit about building mobile applications using React Native. So before we get started, has anyone actually ever used React Native or React at all? Anybody? Raise your hands. Like 3, 4. Okay, cool. So this will be kind of new for most of you. What is React Native? Essentially, it's an open source framework just like NativeScript for building native applications using JavaScript and React. And it does support iOS, Android, and the Universal Windows platform, which is pretty cool. Both Android and Windows are fairly new. How is it different? Basically, it's different from native development because it's one code base, but kind of different. So you actually write different APIs for different platforms like iOS, Android, and all those types of things. But essentially, you write 75 to 80%, if not more, of your code, and it's shared cross-platform, which is really nice. So if you need that extended functionality in iOS or Android or any of those platforms, you can have it, and it's fairly easy to set up with React Native. But if you don't, it's pretty easy to just use the common API and write for both platforms or all 3 platforms. And the way it works, I don't have a graph or anything like that, but essentially there's 2 threads. There's a main UI thread that actually runs native code, and a JavaScript thread that runs non-blocking to that. So if you have some extensive and high CPU usage JavaScript running, it's not going to block the UI frame rate at all. So that's awesome. If you have a list view or anything like that and you're running processes in the background, it's not going to slow that down. You're still going to get around 60 frames per second, which is pretty cool. And another thing that's nice about it is it's heavily extensible. So there's a really solid native API. So if you did want to write in functionality that doesn't exist using Objective-C or Swift or Java or whatever, you can do that and bridge it in pretty easily. So some of the benefits are just like NativeScript, it has live reload, hot module replacement, so you don't have to build and compile every time you make a change and every time you want to run the application. Another thing that's really nice about it is there's debugging in Chrome, so you can actually run the application and the JavaScript thread will run on your laptop, so you can actually look at the console in Chrome and see your errors or anything along those lines. And then it's got a large active community, which is nice, a lot of third-party plugins, things like that. Inherently, it runs ES 2015 JavaScript, no tooling or anything required, which is awesome, so you don't have to set up Webpack or Grunt or Gulp or anything like that. And then just like NativeScript, you can take advantage of a lot of various NPM modules, as long as, like you said, they don't try to do anything front-endy or try to do anything too crazy. So some of the drawbacks are it's not very mature yet. It's in version 0.29, which actually came out today. Kind of broke a couple of my things. That's okay. Like I said, API changes are fairly breaking, so if you do have a new API come out, a lot of those third-party plugins that you're going to use will break, and it's annoying, and you have to figure out why and submit requests and all those types of things. And it lacks some common native functionality like video playback, which was difficult for a video playback app. And then camera, audio, gyroscope, and things like that. Yeah, I took this on before I realized that, but you know what? We figured it out. So basically the way it works is you go to the website, you install the command line tool, and once you have that going, I'll kind of show you the process of setting it up. I don't know if you can see this at all. We'll just make it really big here. And all you run is React Native, init, and then my app. You run that process, it's just going to run that command, spit out a basic demo app. You don't have to answer any questions, and it's pretty much all there. So I guess when we jump into this, I'll start a project. And it's pretty simple to run. You don't have to build for iOS or Android or anything like that. It's built into the command line tool. So to run this, I have a demo app that I'm going to just walk through a little bit. So to run this, you do React Native run, whichever platform you want to do. I'm going to do iOS. You hit run, and it's going to compile out your native code, and then it's just going to run this JavaScript bridge so that your application can run in the emulator. So right now it looks broken. Right, so this is what you get to whenever you first build out a React Native app. Like I said, this is fairly similar to just building, oh, nice. There we go. So it's pretty similar to building out just a React web application. The APIs are pretty similar across the board. The only thing that's different is instead of using divs and spans and things like that, you use view components and text components and all of those types of things. So I guess I'll just jump into a little bit of code, and we can just kind of go from there, and I'll show you essentially how it works. So basically you have to import React and your component, which is basically just a API from actually React, not even React Native, that is just a class that exists that you extend to build views and things like that. And it's nice because it does use React, so you don't actually, breaking changes to React don't change anything on React Native, and vice versa. So you import globally React and component from React, and then you import all of your components from React Native. So the way it works is there's a lot of different, the API is pretty well documented on the website, but basically everything is a component. So view components are like divs. They contain things. They're just containers for your application. Then there's text components, list view components, and things like that. And you basically write it out in JSX, which I don't know if anybody's familiar with JSX, but it's essentially XML or HTML, whatever you want to call it, in line with JavaScript, which a lot of people hate. I'm not one of those people. I actually kind of enjoy it. So let's get started. I'm just going to write a really simple application and just kind of show you what it looks like when you build it out. So I'm going to import view, text, and touchable opacity, which is just, just a button, basically. So whenever you press on that, it's natively going to run a view that has some sort of opacity to it. So all you have to do, just like you would in ES 2015, you export default so that we can get this demo app, call it rn demo, and then it's going to extend components, and I have to call it a class, so I will do that. Right, so that's just saying my class that I'm creating, React Native Demo, extends the React component, which is just a component that React provides. So within React and React Native, there's basically things called Lifecycle Methods, and those are just functions given to you by the API of React or React Native that it's going to run through every time it runs an application. So there's things like component will mount, component did mount, and then the basic one is render, which just renders your application. So we're going to write a quick render function, and then you have to return within that function. So we'll do a view, and then within that view, can't spell, okay, and then within that, we're just going to do a simple text component that says hello SGF web devs. Yes, I can. There we go. Sorry, I was not looking up there. Okay, so this is just a simple React Native view, basically, and it's just going to render some text that says, hello, Springfield Web Devs. So if we go over here and we look at this, we have broken it. So return, there you go. Oh. That's weird. Oh, okay. There you go. Spelling is important. So anyway, if we go back here, it is still broken. I cannot spell. What in the world? There we go. Okay. Sorry about that. I do not know how to use the internet. Jesus Christ. Okay, cool. So we've got it. So basically the way it works, sorry about that, is styles, like I said, are inline. And so React Native provides you with a method called style sheets or components. So we have to import that up here. And then down here, we just define styles equals style sheet dot create. And it's just a function with parameters of an object. And so we'll create one called container. And then it actually uses a port of Flexbox, which is really nice. So it's not the full Flexbox. You can't use like flex reverse or anything like that. It's just justify content, align items, flex direction, and then flex with the number afterwards, which is really nice. So we'll give this flex of 1 so it fills the screen, flex direction of row, justify content of center, then align items of center. And then if we give that to this view container, just say style equals styles.container. Make sure everything is spelled right. And then, geez, you guys, I can't spell. Oh, yeah. That's what you guys are here for. Style sheet is not defined. There you go. Jesus. Okay. Oh my God. Oh yeah. So it's a lot harder when there's a lot of people watching you. Okay, there we go. That should have been a lot easier too. But anyway, Flexbox works in React Native, which makes layouts super easy, which is really awesome because, like you said, laying out things with absolute positioning and things like that is tricky. There's no percentages in React Native, so you actually have to use either Flexbox or there is a component called dimensions where you actually get the width and the height of the current frame that you're rendering into. So that's essentially how it works, and like I said, on the React Native documentation, there's a lot of different types of components that you can import, list views, and things like that. So now I'm just going to jump into the actual code for this video player that I built and show you a little bit. So make this a little bit smaller. Essentially, you have an index.ios.js file that comes standard with everything, and this is what React Native looks at first. And what's nice about React Native is you can actually name things to read. It can intelligently read the files and know if it should pull in Android or iOS. So you can create two files with the same name, one with the extension of .ios.js and one with the extension of .android.js, and it'll actually pull in intelligently whichever one of those that you need. So that's nice. You don't have to write any if-else statements or anything like that. So essentially, we have a module or a file that I'm exporting called quipvid that I then render to the view, which is you do that with this app registry.register component, and you only have one of those per application, and it basically just renders it out into the main view thread of iOS or Android or whatever platform you're using. And so if you go into this quipvid file right here, so we have pretty fleshed out React Native components, React Native file. Like I said, there's a lot of missing native functionality here. So I have actually a search bar that I'm pulling from a third party that's actually the iOS search bar. and then all of the rest of these things are importing in. I'm using a state management framework called Redux, which basically dispatches actions and sends state back to the top of your application, so you don't have to kind of push up through a bunch of different files to get the data that you need, but I won't talk about that here. So essentially I have a header components, a view row components, and a video player components within my app. And the app is pretty straightforward. Like I said, there's a bunch of lifecycle components. So component will receive props, component will unmount, component will mount, things like that it will run automatically for you. You don't have to call those explicitly. So in here I have this render method that just returns a loading view if I don't have any videos, which I just get from an API call right here in component will mount. So this .props.fetch videos is a function that I wrote, just a basic HTTP call that pulls in videos from that QuipVid API. And then the nice thing about React and React Native is it uses state and props to intelligently update the view. So instead of explicitly telling it, okay, I have new videos, I need to push those into this view and then re-render, it just reads from the state and the props, and basically uses a thing called the shadow DOM, or in this case the shadow UI, that diffs the actual UI with a fake UI just to make sure that they're clicking on the same page. If they're not, it pushes the updates that it needs, and if they are, then it doesn't do anything. So yeah, I have this render method that just returns a simple view, like I said, with a style of flex, my header component, which is just a UI nav bar, and then this list view, which is a React Native component that comes standard. So basically what you do is you have to define the data source in this list view with the response from your API call, essentially. And then there's a render row method that comes with it. And so instead of using children components to render the data in this list view, it calls a function that then renders another functional UI element. And in this case, it's called render row. So if you go up here, I'm returning another React component that I call video row, which I then give props of the video itself. And then play video is a function that needs to be on this higher level component. And I pass that down. The nice thing about React Native 2 is you can pass functions as props. It treats them as first-class citizens. So you can actually call a function from within a child component, and it'll call that on the parent component and run any state management type of things that you need. So in this video row, this is kind of where most of the magic happens, which I just have tucked away in a file called video row. So we have touchable without feedback, touchable opacity, and all these React Native methods that I'm pulling in. So we have a class of video row, which, like I said, extends components, and then static prop types, static default props. This is just a way to define what kind of props this component can receive, and if it gets a prop other than video of type object, then it's going to throw an error, and it's going to tell you exactly where that's at. So that's really nice. The error handling in React Native is pretty great. In order to share the videos, that wasn't actually natively built in either, so I had to pull in a third-party API called ActivityView, which is the same thing as iOS, but ActivityView.show, which basically just renders that native share functionality that he was showing you before. So within this render, we have a touchable opacity that contains the entire thing, as you can see here, and that's so that basically touchable anything is the only things that can accept press events. So you have to use touchable opacity, touchable without feedback, and things like that. And that allows you to have an on-press event that's going to call a function that in this case plays the video. And so you can look through here, and there's another touchable opacity here where I call this the share video function. And like I said, you can pass functions as properties. So in React and React Native, you have the component name, and then anything that comes after that, on-press equals whatever, is a property that you're going to pass down to a child component. And so within this, we have that as well as the actual link to the video and then some text. So like I said, React Native doesn't come with a video functionality at all, so I had to pull in, just like he had to pull in NativeScript video player, I had to pull in React Native video player, which doesn't really come with a lot. It basically will play the video, and it has no controls or anything like that. So there was a lot of stuff that I had to build out there, which wasn't really as bad as I thought it was going to be, but yeah, that's one of the negatives of React Native is some of those things just don't exist, and you have to create them yourself. So within here, you basically have to, any function that's not a React Native lifecycle method like render, component will mount, you have to bind to the method itself, to the class itself. And so you basically just do that in your class constructor up here at the top. And then here we have a component will mount, which sets a bunch of pan responders so that we can have gesture controls and things like that of the video. And those are pretty standard. That's pretty well documented within the React Native documentation. There's onMove should set responder capture, onMove should set pan responder capture. So basically it's saying whenever you touch down, start listening for move events. Whenever you move, update these properties, and whenever you stop, call this in function and do whatever I tell it to do. So I have all of those set up here, and that's how I'm handling animations in the actual app that I built, which I'll show you in just a second. And then in here we have this nice video component that looks just about like everything else. That's the nice thing about React Native, is kind of all the APIs are pretty stuck to the standard syntax that you kind of have to follow, which makes it pretty easy to learn a lot of the third-party things and implement your own. And so like I said, this video component has a lot of rate control, source control, pause, download, volume, things like that. And these are just functions that I'm calling that I declared up in the top of my application. And yeah, I mean, that's essentially all there is to React Native. You've got components, you've got properties and state that you pass through to those components, whether that be data from an API call, Native video application, the QuipVid application that I built, and I can show you some of the features that React Native has built in. And it does have things like performance monitoring and inspectors and things like that actually built in, like you'd find in a browser, that are built right into the emulator, which is pretty cool. And I'll show you those as soon as this gets up and running. I might have changed something here. So let me make sure I did not. Here we go. Okay. Oh, there we go. Okay, we'll run that one more time. Sorry about that. If you have a process running from a previous application, then it breaks the build. So you kind of have to clear out all of those before you start this process. But now this should work. Let's see. Anybody have any questions about anything before this thing is up and running? About how React Native works, or?
This is a small question.
Yeah.
One of the last bits we saw.
Yeah.
There's quite a few things wrapped in animated view. Was that the
that's. Yeah, and I can go over that in just a second. It kind of makes more sense to show it and then talk about it, I guess. So this is basically the app that I built. Pretty standard. Lost connection for a second. Pretty standard, just like his. It has a loader and then this status bar up here that was my header component, as well as a little bit of search functionality. So I can search for a video if need be, and then pull that up. And then
go for like.
This is my back, man. This is you as an old man. I'm ugly and I'm dead alone.
I'm gonna let him have this one. All right. Well, I'm sorry to hear that, future me. What a terrible thing. I'll talk to you in several years.
So this is the video player that I ended up having to build. The only part that comes standard with this package is the actual video player itself. So you kind of have to build out all the UI components yourself, which didn't really end up being that big of a process. React Native makes it pretty simple. This is a native React Native slider, as well as this play button, pause button that I created. And that's nice because you can actually use just state to, when I click on this and change the state of the application, whether it's playing or not. That's just a state that I change in my constructor. And then as I change that, it intelligently re-renders based on what state I'm passing to it. So
that player gave you those methods?
It gives you the methods. It just doesn't give you any sort of UI, which ends up working out. there's a lot of things that would be nice to have with this that you kind of don't. But for the most part, it works pretty well. It works both ways, portrait and landscape. And then that animated view that was in there. So there's different view types that can be wrapped in an animated container. It's like animated.view, animated.listView, things like that. And that's where you can pass in animated values. And it makes it a lot easier to work with animations than it does in native code, but it's a little bit trickier than it would be with using transitions or things like that in actual web development. But it ends up being really nice because it uses native animation APIs. So this has this nice spring back into place while you're dragging it, and then if you pull it down all the way, then it disappears and stops playing. So that's pretty nice. And that was relatively trivial to build. And then, like I said, the share functionality is built in. So you just click on that, and there's no Facebook or Twitter or anything on here. But essentially, if you click on that, it's going to use the native share functionality. I can talk about this animated view really quick. I feel like I'm close to being out of time. So yeah, this is a simple animated view, animated.view. And then it's really nice. As long as you wrap it in that animated.view, you just wrap the animated value and put it in the style property. So you just say height equals this.props.animated height. And then anytime that number animates, it's going to animate that view back and forth just like I showed. So that's essentially it. Pretty similar to developing in React, pretty similar to developing for the web. There's a couple things that are kind of finicky with native types of things, but it makes it pretty easy to build applications that you can port to 3 different platforms. So if anybody has any questions or anything like that.
Do you have to use ES6 classes?
You don't. No, I just like it better. But you can use just standard ES25 or ES5, and it's just react.create class, and then it's a function instead of an actual class declaration. So yeah. Yeah.
This isn't so much a React question as much as it is. I'm curious, and I think anybody in the situation of needing to build an app should be curious about this. If you were tasked, right, with client wants this, somebody wants this, whatever, you build an app. Do you have any pause at all about using something like React Native? Like, is there bits that scare you about being limited to its platform and not being able to achieve stuff?
I think it depends a lot on what the application is. If it's a list view of information or something as simple as just playing a video, I would have no pause at all. But if it came down to heavily using native APIs that aren't supported, I would not go with it. Just because you have 2 options. You either write the Swift or Objective-C or Java to port it into it, or you find a native or a third-party plugin, and like I said, it's not stable enough yet to support those for longer than a couple weeks. So it's fun to develop in right now, and it's definitely production ready if you use it for basic things, list views and things like that. But if you're building like a Snapchat clone or something along those lines, there's going to be a lot of native functionality that you're not going to have access to, unless of course you can build most of the UI with React Native, and then you have someone that can write the Swift or the Objective-C to back it up. And then I wouldn't have any pause doing that either. So I guess it just depends on the developer and the client or the situation. So yeah, cool. Anything else? Awesome.
I won't judge you.
All judgment. All right, so you know that redheaded stepchild that nobody wants? Not this guy. Guess again. Cordova. Okay, so for those of you who don't know me, I'm Fred. I do make jokes, so fair warning. Okay, so Cordova is made by our friendly folks at Apache. They're our local web server provider, and they do fun stuff. So, is calling Cordova the redheaded stepchild the unwanted redheaded stepchild a fair assessment? I don't think so. It's definitely made for web developers. It uses all of your familiar technologies like HTML, CSS, and JavaScript. It's highly extendable, so like React, like NativeScript, you can create your own plugins in Objective-C or Swift or Java and bring them into your app. There's a quick project turnaround. So I don't know about you guys, but I was kind of thinking of it during the presentation, or the previous presentation, about all the React Native, and I was like, whoa, that's very verbose. So you will get a quicker project turnaround, especially if you set it up right. And it is cross-platform, and that is specifically because it runs in a mobile web browser. And we'll see a little bit later as to why that's a big problem, because unlike React Native or NativeScript, running in a web browser has its own limitations, such that you're kind of contained within that web browser, as we all know. But fortunately, there's no IE, so that's good. Features. There is CLI, Select React, like Native. What was yours? NativeScript. There is also a CLI tool to build up a project fairly easily. You can install plugins through the CLI tool. There's lots of documentation. It is highly mature. Cordova has been around for quite some time. I don't know the specifics of it, but I can't remember if PhoneGap is a fork off Cordova or Cordova is a fork off of PhoneGap, but it's been around for years. And there's plugin APIs, so you guys can create your own components. Caveats. Performance. Okay, so this is a biggie. Unlike native apps, you're going to have a huge performance hit when working within a browser. It was mentioned earlier about the whole scrolling thing. We'll see here in a little bit as to why running in a browser would cause these sort of effects, and I can also provide some solutions that I was unfortunately way too lazy to implement. Cordova is a huge hack. That's right, I said hack. Clearly, mobile browsers should not be apps, but you know what? These folks found a way, and they made it happen. So, without further ado, let's do the presentation. I did not have this set up beforehand, so sorry about that, folks. Quick vid. Literally, my app is an HTML file with, oh wait, we need to make that bigger. If I know how to. Do you know how to zoom in on?
No.
Okay.
I always forget. Try shift, and then type in zoom. Shift.
Oh, wow.
Zoom. Hey. Nope.
Did it work? No.
It was worth a shot. You would think it would be that.
Well,
Try shift. Size. Oh, increase font size. Oh man. Oh.
well now.
That's better.
Hold on. We'll, you know what?
Try to script quick.
I have an idea. We will just do this. And we will go into here. So part of the structure to this, or what I particularly like to do with Cordova is I like to have two separate folders, one for your actual project and one for the app. And then what I do is I symlink them in as a www folder. So this allows me to test on the browser and do everything on the browser. And then when it comes time to deployment or testing on the actual device, I can swap over easy enough, and I don't have to do any manual building or anything like that. Also, it's great for Git, so if you have Git ignores, you can ignore all the crap and leave what's necessary. So yeah, this is literally my my only view file. So Cordova does allow you like running like running on your local machine without even having a server, honestly. You can literally have your own index.html in a directory, open that up in a browser, and have a link to another HTML file. We already knew that. I don't know why I'm explaining it, but it works the same way here. So you don't necessarily need to have a single view app. You don't necessarily need to have a whole bunch of other files. You literally just need HTML files. Now, granted, there are cases where you're going to want to use something like Angular or, I don't know, something else like React to do single page apps, but I found out that working on this that most of my frustration was actually trying to get the build tools to work. So maybe I'm stuck at JavaScript, I don't know, but build tools are not my friend. Anyway, so this is the HTML page with some meta information. I had to remove one line of meta from here that kind of blocked API calls through JavaScript, like AJAX calls. So I removed that and everything worked fine after that. I just have a div, a search, a UL element for my video list thing, and just include the scripts right here. And literally my script is just this. The entire app is running on this one file. So fairly straightforward, fairly simple. This is ugly, but who has time to build out templates? And then just a few event bindings and we're set. So let's go ahead and run that. Alright, so it's as simple as Cordova run. Excuse me 1 second. I'm pretty sure there's a way to do live reloading and among other things, but I don't know. It built quick enough, I think, because really all it's doing is just moving files from the www folder into the platform folder to show the it moves it into the platform www folder and then it runs off of that. So there's really not much to it in terms of building. The only time where it would take quite a bit of time is if you have a crap ton of plugins put in here. I am using two. One for the status bar. Cordova by default is a little weird with the status bar, so I had to download and use Cordova's native, or a plugin that they built to kind of manipulate a little bit so I can get this black background on it and still keep it at the top of the mobile device. I don't know if you guys saw it behind the terminal screen, but wow, that looked pretty crappy when it loaded, right? It kind of all bundled everything together and then it split them all out. So when you import, or when you do an AJAX call for about 400 or so items, right? Well, the web browser has to catch up in parsing the CSS, parsing the HTML, putting it all together, styling it, rendering it, what have you. So this is performance hit number one, right? Loading in all these elements. We saw in the other two apps that it was, pretty snappy. That's not the case here. I decided to go balls to the wall on all 400. So scrolling, you'll notice that it is a little weird. These images are not cached, but they will be. It is a mobile browser. But as you can see, scrolling is a little weird. Now, one solution for this problem is you can load in a certain amount. I unfortunately bugged Mike a lot to put pagination into his API and to add a caching header, none of which I used. But a smart developer would use that and preemptively load in as you scroll the next pages, cache them, and then only show certain ones within the view, etc., to kind of keep this a little bit smoother. I might have scrolled way too much, so let me go back up to the top real quick.
Well, if you click the bar up top, will it scroll up automatically?
It's a web browser. I'm by no means a UXer, so pardon me on this. So searching. So I had to be a little crafty with this, especially with the jQuery. I just kind of did a search on the elements themselves. I would have animation, and I did have animation, but with 400 items, it got pretty wonky pretty quick. So instead, to kind of compensate for that, if I type in Family Guy, instead of doing animations, it's just show and hide of elements. So that was kind of a pretty big performance improvement right there. But usually with the slide up and slide down, it was just like the entire time, and I was like, nope, not having that. Share
next thing in UX.
Right, yeah. So share functionality was not built in. I did have to find a third-party library for it, but as all the others, it turned out pretty nice. Unlike their emulators, I got a little reminder, so I can remind myself to, again, not UX, but gotta love autocomplete. So I just made myself a reminder of the quip vid. Playback. Do we really need a video player in our apps? I mean, we're web developers. Come on. Take one to Amazon.
Anybody see any good movies lately?
Well, I'm not too much of a fan of that one. My favorite one that distracted me the most during development was this one. It was 4th of July. I built this in 4 hours, so...
So you're going to tell me that you don't have no black cats, no rolling candles, or screaming babies? No. Oh, come on, man. You don't got no lady fingers, fuzz bottles, sneaker bombs, church burners, finger blasters, gut busters, zippity doo-dahs, crap flappers? No, I don't. You're going to stand there, owning a fireworks stand, and tell me you don't have no whistling bumholes, no spleen splitters, whisker biscuits, honky lighters, hoosker do's, hoosker don'ts, cherry bombs, nips and dasers, with or without a scooter stick, or one single whistling kitty chaser? No. Because snakes and sparklers are the only ones I like.
I wish I had fireworks when I was building this. Just saying. That is that. Any questions?
How hard would it be to wrap this in like a pre-existing JavaScript app? Like, because my understanding is like Cordova is more portable for existing apps.
Can you rephrase the question?
Like, if you already have a web app, and how hard would it be to wrap it so it's ready for?
Okay. Well, it depends what it is. So you can't really think of this as like something you can just throw up on a server, right? It kind of takes a different mentality to it. So usually with your current workflow for building websites, you're working with some sort of server, right? You're sending requests out to fetch your assets to like some CDN, pulling them in, and you kind of have like a PHP or some sort of backend, right? Well, with this, there's no backend, so really it's kind of like a WYSIWYG, So if your application is set up as strictly JavaScript and HTML, has no backend functionality, you should be able to wrap it up pretty quick and be able to ship it into a mobile app like this. But you're going to have to do some tweaking for sure. Definitely with the styles. Like pardon my CSS, but I mean, right? So, there's a little. I mean, you're gonna have to make some tweaks, but for the most part, if it's straight JavaScript and straight HTML, straight CSS, you should be good to go. Yeah. Any other questions?
I mean, since it's in the browser, do you get everything the browsers can do? Like,
yes.
Video players kind of come with the browsers now.
I'm sure I can, but I've in the past when working with videos. Just like every browser. So technically, if you think about this, it's actually technically a web view, right? So it's kind of running off of Safari. So whatever limitations the Safari has, this is going to have as well. So I know that sometimes with embedding videos in some browsers have some quirkiness to them, but for this, I just didn't really care to dive into it too much, but I felt it was just simpler to just link it out, because that was the mobile browser when you go back into it. So.
Cool. Does Cordova give you any sort of an API for accessing native stuff on the device?
Mm-hmm. Yeah, it's usually you usually do it through plugins, but I can show you something maybe. It's usually through plugins, and like I said earlier, you can create your own, but so you're going to have your platform-specific plugin that's going to be your Swift or your Objective-C, and then that's going to be kind of like your API for your JavaScript to connect into to start working with it. I draw a picture, but no marker. But I mean, that's essentially how it is. Like, you can. Why not? I don't know how else to say. You just can. I haven't done it, but yes.
Have you played it all around with Ionic, and given the choice, would you go one way or the other?
I've not played with Ionic. I've heard good things about it, but I've not played with it. No.
I think it's essentially a bunch of wrapped up styling and conveniences and frameworks built upon Cordova. So you get Cordova, but you get a bunch of, as you mentioned, getting the single page app concept rolling, and a lot of the styling and stuff is handled for you. I was just curious. 2 spaces. I'd be interested. Sorry.
Oh, your question first, then I'll address him.
So I was just curious, and this isn't specific to Cordova, but like how long did it take you other guys to code your projects? I mean, 4 hours seems pretty quick. I guess it maybe has to do as much with how familiar you are with what you use.
I can't speak for the other guys, but I mean, being a web developer, this was definitely my forte. But I mean, even looking at this JavaScript file, I mean, quite honestly, 102 lines of code for this entire app, I mean, that's not bad. I mean, I don't know about the other guys, but
What was the question? I'm sorry.
How long did it take you guys to
yeah.
To build the apps that we presented?
Yeah.
Oh yeah, so mine took 3 hours.
Yeah, mine probably took like 5 or 6.
Compare that to, so again, I built a pure Swift version of this, and it was probably the first real app I built. So there's, I mean, really kind of years and on and off learning. But I mean, it's taken me a infinitely more amount of time to do it in that. But at least for me personally, my confidence is so much stronger in learning that and in that, the real platform, as opposed to something that's removed from it. But that's just me. I love the web, and I really hope to see it reach a point where we can rely on it just as much to do these, high-performing mobile applications.
But definitely, this is a lot easier to start off with, for sure.
Oh, absolutely. Yeah. And as you mentioned, if you've got a kind of run-of-the-mill app that's got a list of things and parent-child kind of relationship, these platforms might just cut it for those kind of apps. But to a certain extent, even you look at Facebook, and for a lot of it, Facebook is kind of that, right? You've got a list of things, and you look at them. You've got a list of comments, and so I know that's blown out a lot, but Facebook, Sean pointed out the other day that, I mean, they bet big on the web when they were doing their mobile app, and fully went away from that because it just wasn't working for them, because they thought it was going to work out, and it just didn't. And now they've created React and React Native, and that's really interesting. But for high performance things, high volume, even if you got something that's simple and you've got millions of transactions, going on, it's some of these things just might not cut it for you.
So while we've taken a step back and we're comparing the 3 of them, Fred, you said yours is very captive in the browser, and even though there are extensions out there, there aren't extensions that give you access to hardware that...
No, there are extensions that give you access to it.
Outside of that browser captivity, and so it bridges outside of it. So
yeah.
is there anything that you might have seen that you're limited to that they aren't? From that perspective of taking advantage of that hardware device.
That's a toughie because I haven't really dove too much deep into it, but like the status bar, for instance, I did mention that I had to tweak that, right? Yeah, that's completely outside of the browser. So it's literally, it's like a native app. It's just a web view. And that's separated from what a standard view might be. He might have more information about that, but you still have access to things outside of the browser. But as far as rendering goes, as far as running the JavaScript goes, yeah, you're pretty limited to that.
I know Logan said the React Native was kind of young, and so I can imagine some of those things not being available where they are technologically accessible, so we'll get there. With Cordova having been around for quite a while, did you run into plugins that were taking advantage of, gyroscope, different very specific hardware functionality like that?
There was one app many years ago that I've worked on that did make use a little bit of that, more specifically the GPS functionality of the phone. But yeah, I'm pretty sure you can find it.
So camera and all.
Oh yeah, definitely. Oh no, camera's already provided by
accelerometer, those types of things.
Well, okay, so camera is provided by Cordova by default. You just install their plugin. Accelerometer, you're probably gonna have to find a plugin out there, but you just type in Cordova in Google, Cordova, what you're trying to do, and I found the share like that. And got it in.
And I think still there's still limitations. So yes, you can access the camera, you can very easily snap a picture, right? But recording a 40-minute video or doing like a video chat inside of Cordova, I think you're going to hit limitations really fast, if it's even at all possible to do that.
It does do video recording. There's a plugin for that.
Can you trim video, edit video? There's a certain point at which it will stop giving you capability.
I'm sure with the right drive, you could write a plugin that went to the graphics card to start, doing all that sort of stuff. But yeah, that's a huge undertaking. Even for native app developers, that would be a huge undertaking.
We got more Siri integration coming. It'll be interesting to see if you can get, voice recognition inside of a Cordova app. These things will be really interesting.